So in the next set of questions, we're given this diagram at the top, which is another fairly complex diagram. But what we should do is take note of some of the basic facts about this diagram. We have two horizontal lines, M and P, and then we have three lines that are on sort of a diagonal, B, C, and D. They're sort of slanted upwards. And then there's a very short line segment. And the intersection of these lines and line segment creates a number of angles. The statements that follow offer information about the relationship between these angles and then asks the question, which lines are parallel? Okay, given the information in that question, which lines are parallel? So let's take a look at number one, which tells us that if, and this is the information that it provides, the measure of angle 38 equals the measure of angle 39, then which lines are parallel? Okay, so 38 is over here, and 39 is over here, and we're being told that these two angles are congruent, that their measures are equal. Well, one of the ways to think about this problem is to analyze which lines make up each of these angles. So let's take a look at 38 and notice that line M and line D are the two lines that make up the sides of angle 38, and line D again and line P are the two lines that make up the side of angle 39. So these two angles are formed by only three lines, D, M, and P. Well, which two of them could possibly be parallel? D can't be, right? D is intersecting both M and P. So it's got to be that M and P are parallel, but why? Okay, so we know that the answer's got to be M and P, but we've got to justify it. Well, if M and P are the lines that are candidates for being parallel, and D is the transversal cutting the two lines, then what type of angles are 38 and 39? Well, they're on opposite sides of this transversal, D, so they're alternate angles, and they're between lines M and P, which make them interior angles, so they're alternate interior angles. If they're equal, then we have the equality of alternate interior angles, and that is enough to justify that lines M and P are parallel. So we would say M is parallel to P because angle 38 and angle 39 are congruent alternate interior angles. Okay, let's use the same line of reasoning for the other problems. Let's look at the next one. If the measure of angle 42 equals the measure of angle 39, which lines are parallel? Okay, so let's look at what lines make up 42. 42 is made up of line C and line P, and 39 is made up of line D and line P. Okay, so we've got C, D, and P are the only lines involved in these angles. Which lines are the candidates for being parallel? Well, obviously not P, right? P is cutting both of the lines C and D. So somehow we've got to try to prove that lines C and D are parallel. Well, how can we justify that lines C and D are parallel? Well, looking at lines C and D and looking at 42 and 39, what is the relationship between these two angles? They're corresponding angles. Okay, they're both in the right upper position when looked at but from the respective points created by the intersections of these lines. So angle 42 and angle 39 are corresponding angles. We're told that they are congruent, or that their measures are equal. And therefore, line C and line D are parallel because the corresponding angles are congruent. So we can say that line C is parallel to line D because angle 42 and angle 39 are congruent, corresponding angles. Okay, good. Let's take a look at the next sentence. If angle 29 supplements angle 44, which lines are parallel? Angle 29. Okay, let's take a look at angle 29. That's this angle over here. If it supplements angle 44, which lines are parallel? Well, what are the lines that make up angle 29? It's the horizontal line M and line B, and the angles that make up the lines that make up angle 44 are the horizontal line P and line B. So the only lines involved in these two angles are M, B, and P. Well, again, I think you can see B certainly is not a candidate for being one of the parallel lines, right? It clearly crosses the other two. So somehow the candidates here are M and P, and we've got to figure out, can we prove that M is parallel to P? Well, what is the relationship between angle 29 and angle 44? B is the transversal. They're both on the same side of the transversal, and they are both between lines M and P. That makes them same side interior angles. We are told that they are supplementary, that one angle supplements the other. So we are dealing with a scenario where we have same side interior angles that are supplementary, and we just learned that that is one of the conditions that guarantees that lines M and P are parallel. So we can say M is parallel to P because angle 29 and angle 44 are supplementary, same side, interior angles. Okay, good. And finally, our last problem in this section. If the measure of angle 44 equals the measure of angle 39, which lines are parallel? So let's go ahead and take a look at 44 and 39. Let's determine the lines that make up these two angles. It would be line B, line P, and line D. Okay, so you know that's what you need to verify, that it's B, P, and D. And clearly, if it's B, P, and D, P is not one of the parallel lines because it intersects both B and D. So we've got to somehow prove that line B is parallel to line D. Got to prove B is parallel to D. Well, how can we do that? Well, let's look at the relationship between 44 and 39. What kind of angles are these? Again, they're corresponding angles. Okay, they're both in the right upper hand side of the intersection. And we are told the measures are equal, so we've got congruent corresponding angles, and therefore we can conclude that the two lines B and D are parallel. So we have our statement that line B is parallel to line D because angle 44 and angle 39 are congruent, corresponding angles. Okay, and those are the reasons in this section.